Hi everybody and welcome back. We were solving a sample paper and have completed section A and section B up till now. Well, why are we doing that? I told you we want to train our brain so that in that span of 2-3 hours, our brain can recall all the concepts from the wide variety of chapters in our syllabus and that we do not panic in the paper at all. That is why we are practicing questions coming from all the papers at one time. Well, we dealt with section A and section B. It's now time to begin section C. Now, this section constitutes questions from 15 to 24. So, let's start discussing question number 15 and understand what that is trying to speak about. Question number 15, just try to focus. Let's read it. If tangents PA and PB, so it's already given that PA and PB are nothing but they are tangents from a point P, okay, to a circle with center O. So this is your external point P. From the point P to the circle with center O, PA and PB are two tangents to this circle, which are meeting the circle at a single point. PA is meeting the circle at a single point, point A. PB tangent is meeting the circle at a single point, point B. And this circle has center O. Further, it is saying that these two tangents from point P to the circle are inclined to each other at an angle of 70 degrees. So, the angles which they are making with each other is 70 degrees. This angle is 70 degrees. Then find angle POA. Okay, so POA happens to be this angle. This angle is the question mark. This is what we have to find. Now, over here, the chapter which comes into existence in order to sort this question out is your circles chapter, in which you have studied concepts about tangents and how do tangent to a circle behave. Now, the very first thing which I would like to remind you is that suppose this is your circle with a certain center O, and suppose this line which I am going to draw, this is your tangent. What is a tangent? Tangent is any line which meets a circle at exactly one point. So, this line is meeting the circle at this exactly one point, say P. Suppose this point is any point A on this line and this is any point B on this line. Then because this is a line which is meeting this circle at exactly one point P, so this line is a tangent to the circle, correct? Further, we know that if this is a tangent, then something is there which is always existing. What is it which is always existing? Now, this is your center. From the center, what you do, you drop a line which meets the circle at point P. Now see, point P is what? Point P is nothing but the end point of this radius. What is O to P? This length is nothing but the radius of the circle, and this radius of the circle is basically becoming the radius because I have drawn a line joining O to the point on the circle which is P. And this is a tangent which is meeting the circle at point P. Now, I know that any tangent to the circle is perpendicular to the radius through the point P. If I have a tangent meeting the circle at point P, then it will be perpendicular to the radius of the circle through point P. That means this angle or this angle, both of them will be 90 degrees. Understood? Why did I made you recall this particular concept that any tangent which is passing through the circle or meeting the circle at exactly one point P is perpendicular to the radius through point P. Understood? I made you recall this concept because over here something like that is happening. Now AP is a tangent which is meeting the circle at exactly one point A. Now O is the center, so from O to A when you drop a line, this is nothing but the radius. And I told you that the tangent is perpendicular to the radius through the point of contact. The point of contact is A, so it will be making 90 degrees over here. Further, PB is a tangent meeting the circle at point B. This is where the tangent is meeting the circle, and O is the center. So this tangent will be perpendicular to this radius. OB is the radius through the point of contact, which is B, and that is why you have this angle as well to be 90 degrees. That means this angle is something that you know. Further, PBO is another angle which you know. PAO is an angle which you know. You know APB angle is 70 degrees. What is the one angle which you do not know if I talk about the quadrilateral AOBP? So, in the quadrilateral, what is the quadrilateral? You can see AOBP. And how does it look like? Somehow it looks like this. Over here, this is your point A, this is O, this is B, and this is P. Inside this quadrilateral with four vertices A, O, B, P, I know that this angle is 70 degrees. Further, I know this angle is 90 degrees. Then I know this angle is again 90 degrees. That means I just don't know this angle AOB. But I know a certain fact about quadrilateral, that as the sum of all angles of a quadrilateral is 360 degrees. Isn't that true? When you have a quadrilateral, it has four vertices. There are four angles which are possibly made inside a quadrilateral. If it is a quadrilateral, the sum of all those four angles will amount to 360 degrees. That means out of these four angles, I already am aware about three angles. That means inside this quadrilateral, I can say angle AOB plus angle OAP plus angle APB plus angle OBP. All these four angles are going to add up to give you 360. Now among these four angles, you know the value of angle APB, it is 70 degrees. You know the value of angle OBP, it is 90 degrees. You know OAP, it is 90. What you don't know is this angle X. So obvious thing is that you have X plus 90 plus 70 plus 90 equals 360. This means what? You have X plus, what is 70 plus, what is 90 plus 90? It's 180. 180 plus 70 is 250. It is equal to 360, which implies X comes out to be 360 minus 250, which means X is 110 degrees. Or I can say that angle AOB is 110 degrees. The moment you have your angle AOB, That means you don't have this question mark, but you have this complete portion. This complete angle, angle AOB, is 110 degrees. I want this question mark angle. Right now what I have is this angle. Now I want this angle AOP. Let us recall one more concept about circles and tangents. What is that one more concept which I want you to recall? The concept is that if you have a circle, okay, with some center O. Suppose there are two tangents drawn from an external point. So suppose this is some external point P and there are two tangents drawn to the circle from this external point to the circle. And suppose they are meeting the circle at point A and at point B. Then I can complete this figure by adjoining these two and also adjoining P to O. I know that if two tangents are drawn from an external point to a circle with center O, then both these tangents subtend equal angles at the center. The angle subtended by this tangent at the center, which is suppose angle 1, is equal to the angle subtended by the second tangent at the center, which is this angle 2. So I know the first thing, that if from an external point, one external point, I am drawing two tangents at the same circle with center O, then both of them are going to subtend equal angles at the center, which means this angle, angle 1, will be equal to angle 2. And the second thing is that if you consider the line segment PO, this line segment if you consider, then both the tangents, this tangent and this tangent, both the tangents are equally inclined to this line segment. Which is the line segment I am considering? The line segment joining P to O. Then both these tangents are equally inclined to this line segment, which means this angle, say angle 3, is equal to this angle, say angle 4. That is the second point. Understood? Let me repeat, whenever you have an external point and you are drawing two tangents from one external point to the circle with center O, both these tangents subtend equal angles at the center, which means angle AOP is same as angle BOP. Okay? Moreover, if you consider the line segment joining P and O, then both the tangents are equally inclined to this line segment, which means angle 3 is equal to angle 4. Why am I making you recall this concept from the chapter circles? Because over here, the figure itself is somehow making the same information revealed to us. There is an external point P and there are two tangents drawn from the external point to the same circle with center O. That means both these tangents are going to subtend equal angles at the center. That means angle AOP will be equal to angle BOP. So this figure also suggests that here, what is it that I am going to have? I am going to have that both the tangents are going to subtend equal angles at the center, and so angle AOP will be equal to angle BOP. Okay. Somehow we have come close to the angle that we wish to find. Angle AOP is same as angle POA, and we have somehow come close to angle POA or angle AOP. Now let's go back and see what was the thing that we had found till now. Till now we had found angle AOB is 110 degrees. carefully observe. Can't I say angle AOB is equal to angle AOP plus angle BOP? Because this large angle is nothing but the sum of this and this. Correct? Therefore, angle AOB is equal to angle AOP plus angle BOP, okay? But there is a twist in the picture. Why? The twist is that angle AOP is same as angle BOP. That means I can write BOP also as AOP. Because AOP and BOP are two angles which are same. Their measurements are exactly the same. That means this becomes what? This becomes nothing but twice of angle AOP. And therefore, angle AOP is nothing but half of angle AOB. I know what is my angle AOB. It is 110 degrees, and therefore I get this is half of 110 degrees, which means 55 degrees, and thus angle AOP, okay, AOP, or I can say POA, both are the same angles, the question mark angle which we were supposed to find, and that has come out to be 55 degrees. That's how beautiful this question is. The only two concepts which were required to tackle this question were, the first one was that if this is a tangent, so it is going to make 90-degree angle with the radius of the circle. This was again a tangent, so again it is going to make 90-degree angle with the radius of the circle through the point of contact. Once this concept was known, you came to know three angles of this quadrilateral AOBP. And the moment you know three angles of a quadrilateral, you can very easily find out the fourth angle by using the angle sum property of a quadrilateral, that all the four angles in a quadrilateral give the sum to be 360 degrees. The moment this concept was used, you were able to find this large angle at the center, angle AOB. And then we moved on to using the second concept related to circles and tangents, which was what? That concept basically said that if from an external point you draw two tangents, both of them are going to subtend equal angles at the center, which means using this particular property, I declared that angle AOP will be equal to angle BOP. That means angle AOB will be twice of this question mark angle. This angle AOB is nothing but double of this question mark angle. And I know what is angle AOB. So this question mark angle will be half of angle AOB, and by doing that, I found that this question mark angle was 55 degrees because double of it is 110, which is this angle AOB. That's how beautifully, by just recalling certain very easy basic concepts about tangents in circle, you can deal with this particular question. I don't think it was at all a difficult question. The only thing required was to recall the concepts which can be used very nicely, very directly in this particular question. Let's now move to the 16th question and deal with that in section C. Okay, what is it trying to say? Let's quickly read it. There is an electrician, okay fine. He needs to reach a point 1.6 meters below the top of the pole of height 8 meters. Okay. So there is a pole of height 8 meters, an electric pole, electricity pole. There is a pole. Suppose this is your pole, and over here when I'm saying this is the end of the pole, that means this is the ground level. Suppose this is your electric pole. So this pole has height 8 meters. That's what is given in the question. There is a pole of height 8 meters. Now this electric pole, an electrician is basically interested in this pole. Why? Because he wants to repair something in the pole maybe. So what the electrician wants to do is he needs to reach a point 1.6 meters below the top of the pole. So this is the top of the pole. The electrician wishes to come down 1.6 meters down from the top of the pole. So let's do that. The electrician basically needs to come somewhere here. And how much is this distance? From the top of the pole, he wants to travel 1.6 meters below to reach to a point over here. Because the question says that it is there that the repair work needs to be undertaken. The repair is somewhere here to be undertaken, which is nothing but 1.6 meters below the top of the pole. That means the electrician wishes to come at this point to repair something in the electric pole. This much is the information delivered from the question by now. Further it says, if he has to incline the ladder at 60-degree angle to the horizontal. Now this is the ground. Somewhere here is your electrician. Now this electrician wishes to come over here at this point to undertake the repair work. He will have to use a ladder to come above. That is what the question is suggesting us. If he has to incline the ladder, this is the ladder. Suppose the electrician wishes to incline the ladder at 60 degrees. Okay? The question says if he has to incline the ladder at 60-degree angle to the horizontal, that means what he is doing, the electrician, he is picking up the ladder and inclining the ladder. This is a ladder. He is inclining the ladder at 60-degree angle to the horizontal. The question says, what do you think should be the length of the ladder to enable him to reach the required position? He wants to be here. This is the required position. And so the ladder is inclined at 60-degree angle. The question is, what do you think should be the length of the ladder? So the question is asking you to find out this length of the ladder, right? That is what is the information given and that is what is the question asked. Now, if I wish to find this length of the ladder, what is it that I will have to do? Now, one thing will be very, very evident from this diagram, which is that this angle is 90 degrees, correct? This is an electric pole, it's always straight perpendicular to the ground. The ladder is inclined at an angle of 60 degrees to come and meet the pole over here so that the electrician can come, climb the ladder, reach this position and do the repair work. If this angle is 90 degrees and I somehow just mark the positions, this has A, this has B, this has C and say this has D, then triangle ABC is a right angled triangle. This is a right angled triangle. Now in this right angled triangle, let me separately make it. You have information about this angle. In this triangle, you have information about this angle. You don't know what is the hypotenuse length. This is the hypotenuse, the slant height of the right angle triangle is known as the hypotenuse. You don't know what is the length of the hypotenuse. That means you don't know the length of the ladder. But do you know the length of AB or BC? Do you know the length of any of the two remaining sides of this triangle? Yes, you do. Well, if DB is 8 meters, DA is 1.6 meters, don't you know what is AB? What will be AB? AB will be nothing but DB minus DA. From this entire thing, if you subtract this much, you are going to be left with this much. So, DB minus DA is your AB. That means 8 meters minus 1.6 meters is your length of AB. And what is that? 6.4 meters. That means this length from A to B is 6.4. Now inside a right angle triangle, if you know one acute angle and you know the measurement of one of the sides, you also know which is that side whose measurement you wish to find. Well, that means you have the angle 60 degrees, you have the information about the perpendicular, you have the information about you don't have the information about the hypotenuse, which is that trigonometric ratio which is going to connect perpendicular with the hypotenuse corresponding to this angle 60 degrees. It is the sine ratio which connects perpendicular to the hypotenuse. And so let's use the sine ratio. I know sine 60 degrees is equal to perpendicular upon hypotenuse. Perpendicular is AB. Hypotenuse is your AC. What is sine 60? Sine 60 is root 3 by 2. What is your AB? AB is your 6.4. What is your AC? AC is nothing but the length of the ladder which is asked in the question. I don't know what that is. That is what I wish to find. So everything is known to me, only one unknown is there, so I can definitely find the value of that unknown. Therefore, AC becomes what? AC is equals to 6.4 into 2 divided by root 3, which means this is what? 12.8 divided by root 3, which brings it to 12.8 into root 3 divided by root 3 into root 3. Multiplying and divide by root 3 because generally we don't leave the answer at a point where root number is lying in the denominator. So in order to kill that, we multiply it again with the same root 3, and in order to make stable the entire situation, we also divide it by root 3. And so you get 12.8 into root 3 upon 3, which makes it 4.26 into root 3 upon 1. Now this 3 cancels 12.8 and it comes out to be 4.26. You have 4.26 into root 3 divided by 1. Now root 3 you know is 1.732, which when you find out comes out to be 7.38 meters. That means the length of AC is coming out to be 7.38 meters, but this AC is nothing but the length of the ladder, and therefore the length of the ladder is coming out to be 7.38 meters. Pretty simple question. The only task is that you should be able to interpret the question and relate it to trigonometry. And the very first trigger which made me do that was this 90-degree angle. The moment I got this right angle triangle, I tried to understand which is that ratio which connects perpendicular to the hypotenuse through the 60-degree angle, and sine ratio is the one which does that. The moment you decode that sine ratio is the one which does this, after that the question is very, very easy. You just have to solve algebraically. Nothing else remains a task. And so I'm going to rate this question to be pretty easy question. Even the situation which needs to be interpreted mathematically is very, very easy in this question. Okay? Now let's move to the next question, hoping that you have understood completely this question. Question number 17. Question number 17 says there is a point P which divides a line segment joining 2 points A and B such that AP upon AB is 1 upon 3. If this is the scenario which is there, what do you think will be the solution of this question? Okay, let's do that. Point P is dividing the line segment joining 2 points. So, suppose this is your point A, the coordinates are 2, 1 and this is your point B, the coordinates are 5, -8. Understood? Now, this is the line joining these 2 points and point P is somewhere coming here with I don't know what coordinates, which is dividing this line segment joining A and B in which ratio? 1:3. Yes, because it's given AP upon PB is 1 upon 3. This means P divides the line segment AB in the ratio 1:3. Very easy. So what is the question? If this point P along with lying on the line segment joining AB is also lying on some other line, say this is the line over which also this point P is lying such that this line has the equation 2x minus y plus k is equal to 0. What is the question? The question is very interesting. There is a point P which is dividing the line segment joining the 2 points A and B in the ratio 1:3. I don't know what that point is, so the first task will be to find that point. The next thing is given to me that this point not just lies on the line segment joining AB, but it also lies on the line which is 2x minus y plus k equals 0. Give me the value of k from all this information. The first thing which comes to my mind the moment I look at the ratio 1:3 and I know that point P is dividing line segment joining 2 points A and B in some ratio, section formula has triggered inside my mind. What does the section formula say? Section formula says that if you have a point or 2 points A and B and there is a line segment joining these 2 points with coordinates x1, y1 and x2, y2. Also there is a point P which divides this line segment in the ratio m1 is to m2 such that I don't know the coordinates of this point. If there is a point which divides this line segment joining A and B in the ratio m1 is to m2, then by the section formula, I can know what are the coordinates of the point P which is dividing the line segment joining A and B in the ratio m1 is to m2. Okay? This is something that is known to me now. Now, what is the first coordinate x by the section formula? X is nothing but m1 x2 minus m2 x1 upon m1 plus m2. What is the yth coordinate? It is equal to m1 y2 minus m2 y1 upon m1 plus m2. This is what it is. Now that I have revealed to you the section formula, that means I have revealed to you if you know the 2 endpoints of a line segment, how can by section formula you can find out the coordinates of the midpoint. Why don't you try plugging in the values of m1, m2, x1, x2, y1, y2 and find out the coordinates x and y of our point P given in the question. Do that and then I'm going to come and proceed with you further. Okay students, so could you do it? Well, this is the very common mistake done by many people here. Over here, the formula is not m1x2 minus m2x1, rather it is m1x2 plus m2x1 upon m1 plus m2. No change in sign in the numerator and denominator. And m1y2 plus m2y1, below also a plus sign. Everywhere in the section formula, the formula for finding out the coordinates of the point P which divides the line segment joining A and B in a certain ratio, there is everywhere a single sign which is a plus sign. Always remember that. That means the moment now I have the formula to calculate the coordinates of point P with the help of these two coordinates and this ratio, let us find out the coordinates of point P using the section formula. So here your x will be what? m1 x2. Understand carefully, this is your m1, this is your m2, this 2 is your x1, 1 is your y1, 5 is your x2, minus 8 is your y2, right? x1, y1, m1, m2, x2, y2. So let's plug in the values in the formula. m1 x2 plus m2 x1. So 1 into 5 gives you 5 plus m2 x1, 3 into 2 gives you 6 upon m1 plus m2, 1 plus 3, that is 4, and x comes out to be 11 by 4. Next, let's move on to y. What is y? m1 y2. So m1 is 1, y2 is minus 8. So 1 into minus 8 delivers you with a minus 8 plus m2 y1. So m2 into y1, 3 into 1 gives you 3 upon m1 plus m2, which is 1 plus 3, that is 4. And this delivers you with a what? With a minus 5 by 4. Understood? So this is your x, this is your y, and thus point P is actually equal to 11 by 4 comma minus 5 by 4. Understood? That is what, these are what are the coordinates of point P. Now that I know point P, let's use the other information given in the question. This point P lies on the line whose equation is given to you. Now whenever you consider a line and you try and draw it, basically that line graphically is the set of or the collection of all the points on the x and the y axis, or basically in the entire Cartesian plane, which satisfy this equation of the line. Basically, if any point is sitting on this line, that means whenever you plug in the x coordinate of that point in place of x over here, and you plug in the y coordinate of that point in place of y over here, and you solve 2x minus y plus k, you are going to get 0 as the right hand side. That means any point lies on a line if and only if it satisfies the equation of the line. So if point P is lying on this line, that means its coordinates x and y, when plugged inside the equation of the line, satisfy the equation of the line. Okay? So as point P lies on the line 2x minus y equal to minus k, I can write it like this. So as point P lies on this line, this implies point P satisfies the equation of this line. That means when you plug in x over here, so what is x coordinate of point P? It is 11 by 4. So you have 2 into 11 by 4 minus the y-th coordinate of point P. Y-th coordinate of point P is minus 5 by 4. So this will be plus 5 by 4 is what is your minus k. Let's sort this out. This is 2. So you're left with 11 by 2 plus 5 by 4 equals minus k. Take out the LCM as 4. You get 2 into 2, so it's 22 plus 5 equals minus k, or you have k is minus 27 by 4. That is what completes your answer, because that is what the question asked you. What was our question given in question number 17? Question number 17 was asking you to find the value of k over here. Understood? And so, with the help of section formula, we have found the value of k. There is one small correction in the question, which is, over here you are given by mistake the ratio of AP is to AB rather than the ratio of AP is to PB. So, over here it's not AB, instead it is PB. Okay? Because whenever a point divides a line segment in the ratio of something is to something, that means you are given the ratio of this portion is to this portion. And so, the ratio is of AP is to PB, which is 1 is to 3. And thus, by a simple use of section formula, we have found out the value of point P. And then by using the concept that any point if lies on a line, it has to satisfy the equation of the line. Therefore, P satisfies the equation of this line, and that gives me the correct answer K, which when plugged in over here is going to satisfy this entire scenario. Okay? Beautiful question concerning coordinate geometry. Okay? That is how interesting this question is, and that is how you need to deal with this question. There were certain number of facts which were used in order to complete this question, but none of them were pretty difficult. Clearly direct use of formulas and concepts, and you are through with this question. Let's deal with the next question, question number 18. Now what is this question trying to say? Just take a small look at it and then we are going to deal with it. Somewhere it's trying to speak about the area. What is the question trying to say? Here the question says, find the area of the shaded region if the diameter of the circle with center O is 28 centimeters and AQ is 1 by 4 times AB. Now over here the diagram which is present is something like this. This is your circle given to you. This is somewhere your center O, and this happens to be your diagram. It says AQ is 1/4 of AB. If this is the diagram which is concerning this particular question, the question is that find the area of this shaded region if the diameter of this particular circle. So you are given the diameter of this circle. Diameter of the circle C is equal to 28 centimeters. Also it's given to you that AQ is 1/4 the length of AB. Now when the diameter of this circle is 28 centimeters and O is the center, any line passing through O meeting the circle at both the end points is your diameter. That means the length of AB, which is the largest chord of a circle, the length of AB will be 28 centimeters. Once you have come to know the length of AB, you are given AQ is 1/4 of AB. So AQ is 1/4 of 28, which gives you 7 centimeters. Now area of this shaded region is area of this portion plus the area of this portion. So let's deal with this portion first and then deal with this portion in the second part. when you deal with the first part, just copy down the first part. If I just copy down the magnified part of this first area that I have to find, this is your point A, this is your point Q, and you know this entire distance AQ is 7 centimeters. Now over here, if I take the midpoint of AQ, and I mark this point as O dash, suppose I take the midpoint of AQ and mark this point as O dash, this particular distance will be now 7 by 2. Okay, AO dash will be equal to O dash Q, which will be 7 by 2. And you can very well see this is a semicircular portion given to you in the question. Because it is a semicircular portion, that is why I can associate this to the sector of a circle with center O dash, radius 7 by 2, and this particular sector. If I take, in this circle, if I take AQ as the arc, then this arc is subtending an angle of 180 degrees at the center of the circle O dash of radius 7 by 2. Then if I wish to find out the area swiped by this particular portion, it is same as the area of this sector, which has angle 180 degrees made by its arc, which is AQ at the center of a circle of radius 7 by 2. The area which is of this sector is the area which is of this particular portion, which is the first portion's area that we wish to find. Understood? And that is why the concept which is required over here is the area of a sector. We know that area of a sector of angle theta in a circle of radius r is given by what? It's given by pi r square into theta by 360 square units. Understood? Right now you know that this sector is a sector of the circle with center O dash, radius 7 by 2, whereas the angle of this sector is 180 degrees subtended by the arc of the sector AQ at the center, and therefore area of the sector AO dash Q, which is same as the area of this particular region, is what? Pi r square into theta. So what is your theta? 180 degrees by 360. Now 180 2s are 360, so this gives you pi r square by 2 centimeters square. This is the area of the first semicircular region inside this circular region. Let's focus now on the second part. Now understand, length of AQ is 7, whereas length of AB is 28. So if length of AQ you know is 7, AB you know is 28, what is the length of QB? Length of QB will be 28 minus 7, right? So, I know length of QB will be length of AB minus length of AQ, which is going to give you length of QB, which is 21 centimeters. And now if I draw the magnified portion of the second semicircular region in this circular region, I will have this. Understood? Now suppose I take the midpoint of QB to be equal to some point P. Now if QB is 21 centimeters, obviously this will be 21 by 2 centimeters. Half of 21 is 21 by 2, and so if P is the midpoint, that means it is making the QB's length cut into half. So half of 21 is 21 by 2, this also will be 21 by 2, and so this implies QP is equal to PB, which is 21 by 2 centimeters. Understood? Now that you know this, my interested region in which I am interested is this one. Now because this is a semicircular region, I can associate it to what? Again I can associate it with this time a circle with center P with radius, the radius being 21 by 2 centimeters. Understood? And this sector, this region is nothing but this particular sector, which is QPB. If I wish to find the area of this region, it is same as finding the area of this particular sector with angle again 180 degrees at the center of the circle subtended by the arc of the sector QB. And I know by this formula that area of a sector of angle theta in a circle of radius r is given by what? So over here, because I know the radius of the circle and I know the angle which is there of this particular sector, I know that area of the sector QPB will be equal to what? Area of this sector will be pi r square 21 by 2 square into 180 divided by 360. Again 180 2s are 360, so this turns out to be pi into 21 by 2 whole square into 1 by 2 square, or I should write centimeters square. That means by this equation I know the area of this region number 2, and by this equation I know the area of this region number 1. I have to find the area of the entire shaded region. That means I have to find the area of region 1 plus the region 2. So let's start finding that. What is the area of the entire shaded region? Area of the entire shaded region is area of 1 plus area of the second region. Now I know what is the area of the first region. It is pi by 2 into 7 by 2 whole square centimeter square plus, what is the area of the second region? Pi by 2 into 21 by 2 whole square. This much. So this plus this centimeter square is my area of the entire shaded region. Let's sort this out. This will be pi by 2 common. You will have 7 square by 2 square, which is 49 by 4, plus 21 square by 2 square, which is 441 by 4, and that is going to give you what? This will be what? 490 by 4. Understood? This will be what? 385 by 2, isn't it? Because this you can write it as 22 by 7 multiplied by 2 into 490 by 4. right? Pi, you can sort this out as 22 by 7, and therefore when you get on solving 385 by 2, you get 192.5 as your final answer. And thus, your area of shaded region happens to be 192.5 centimeters square. Nothing did I do, the entire solving part is left upon you. I've portrayed before you the answer. Just plug in the value of pi over here. You're going to solve this. You're going to get this value, 385 by 2, and which is nothing but 192.5 centimeters square. That means over here in the figure, it was evident that the first region is a semicircular region having a certain radius, which was found using this very relation between AQ and the diameter of the circle, which is AB. After that, we also found that the second region was again a semicircular region with again a certain radius. The moment you know you can interpret them as semicircular regions, the next step is very easy. Just relate it to the sector of respective circles. You know the formula of sector of a circle, apply it, add both the areas because that is going to give you the area of the entire shaded region. Adding up the area of 1 and the area of 2 and then solve it, you get your area of shaded region, which is 192.5 centimeters square. This is what happens to be the dealing with this question. Okay? Now let's move to the next question and see what is that demanding us to do. Because over here, the entire concept was only about the area of a circle. The moment we have realized that the chapter which is used in order to deal with this question is areas related to circles, this question is nothing. It's absolutely nothing. You just need to connect it to the sectors, connect it to the formula of area of a sector, and then you will be through getting the exact correct solution of this question. So as I said, let's proceed with the question you have now, question number 19, related to probability as I can see. The question says in a single throw of 2 dice, so there are 2 dice, a pair of dice basically, and you're throwing it exactly once. Find the probability that neither a doublet, so I don't want a doublet, neither a doublet nor a total of 9, so nor a total of 9 will appear. That means I am interested in getting the outcome which is neither a doublet nor a total of 9. Anything apart from these two situations is my favorable outcome. But these two outcomes are not my favorable outcomes, okay? So the first thing you have to understand is that when you are throwing a single pair of dice, okay, just a single time when you're throwing a pair of dice, what all are the outcomes which can come? You can get, or your sample space will be very easy, you can find this out. How will you be able to write it? 1 in the first die, 1 in the first die, second die, 1 in the first die, 2 in the second die. Then you have 1 in the first die, 3 in the second die. Similarly, 1, 4, 1, 5 and 1, 6. That winds me up with the possibility of 1 coming in the first die and any other outcome in the second die. Then you have 2 in the first die and any outcome in the second die. 2, 4, 2, 5 and 2, 6. Then 3 in the first die and anything in the second die, 3, 1, 3, 2 and up till 3, 6. Similarly, 4 in the first die and anything in the second die up till 6. Then you have 5 in the first die and anything in the second die up till again 6. And last is 6 in the first die and anything in the second die up till 6. That's it. Only 6 are the outcomes which can be produced by a single die. So, from 1 to 6 are the possibilities of coordinates sitting at these two positions. Once you have found the entire sample space, you know that these are the total number of outcomes which can be produced when you throw a pair of dice for a single time. Out of them, I'm not interested in doublets. What all are my doublets? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6 are my doublets. So what are the doublets? I am not interested in this outcome, this outcome, this outcome, this and this and this. This is something I don't want. These are not my favorable outcomes. And also, which are the ordered pairs in which when you add the first and the second coordinate, you get a total of 9. Which are they? Let's see among all of them, which will be the ones which are going to give me a total of 9. Well, in the first die, I can have these 6 possibilities. In the second die, I have again these possibilities. Okay? So, if 1 comes on the first die, what should come on the second die among these 6 such that when you add up both of them, you get 9? Well, nothing. Even if 6, the largest outcome in the second die comes, 6 plus 1 is 7. So, 1 can never come in the first die such that something on the second die will be produced such that 1 plus that will come out to be 9. Okay, so 1 cannot pair up with anything to give you 9. Can 2 pair up with anything to give you 9? No, 2 plus 6 is 8. So, 2 cannot pair up with anything to give you 9. Can 3 pair up with anything to give you 9? Yes. 3 can pair up with 6 to give you 9, that is it. So, 3, 6 is the first outcome such that the sum is equal to 9. Let's move to 4. Can 4 pair up with anything to give you 9? Yes. 4 can pair up with 5. Can 5 pair up with anything to give you 9? 5 can pair up with 4 to give you 9. Can 6 pair up with anything? Yes. 6 can pair up with 3 to give you 9 and that is it. No more possibilities of pairing something with something such that the sum comes out to be 9. These are the only 4 possibilities. That means out of these 36 outcomes, I am not interested in these 6 outcomes and I am not interested in these 4 outcomes. Apart from these 10 outcomes, I am interested in any other outcome. So, number of favorable outcomes to me, what is the number of favorable outcomes? Anything I want is a favorable outcome when anything comes out as the outcome apart from these 10 outcomes. So, number of favorable outcomes is 36 because total number of outcomes is 36. 36 minus these 10 outcomes, which gives you 36 minus 10, that is 26. So, out of the 36 outcomes, these 10 outcomes are unfavorable to me. Therefore, the favorable ones are 36 minus these 10 unfavorable, which means these 26 are favorable to me. The moment I have found the number of favorable outcomes, what is the probability of getting these outcomes? That means probability of not getting a doublet and not getting a total of 9 type of an outcome. Probability is number of favorable outcomes whole upon number of total total outcomes. Okay, number of favorable outcomes is 26, number of total outcomes is 36, which gives you what? 13 upon 18 as your required probability of not getting a doublet and not getting an outcome which gives you a total of 9. And the probability is number of favorable outcomes upon number of total outcomes. Total number of outcomes we have seen is given by the sample space. There are 36 outcomes, out of which unfavorable to me were these 10. So out of those 36, I have removed the unfavorable ones. I am left with 26 favorable outcomes, and the probability therefore becomes 26 upon 36, which is 13 upon 18. This is how you have to deal with this particular question related to probability. Pretty easy question. The only task was to be able to find out the sample space and hence deduce the number of members sitting in the sample space, because that gives you the total number of outcomes. From that you have to remove the unfavorable ones. So first of all, detect which are unfavorable ones and then remove the number of those unfavorable ones. You get the number of favorable ones divided by the total number of outcomes, you get your probability. So quickly note this down, understand the concepts whichever I have used in order to get to the correct answer, and then we are going to move forward with the next question. Okay students, let's now continue with the next question. Quickly read the question and see what it is demanding, and then we are going to deal with it. So what is the question trying to say? It is saying that there is a cone which is cut into two parts by a horizontal plane passing through the midpoint of its axis. That means the question is trying to say that there is a cone a right circular cone. Suppose that's A, that's B, and that's C. Now this happens to be the axis of the cone. What happens? There is a plane which is passing through the midpoint of this axis. So this happens to be the plane passing through the midpoint of this axis AB. So if this point D is the midpoint of AB, because this plane is cutting this axis through the midpoint, that means if the point where it is cutting the axis is point D, this point D is the midpoint of AB, and therefore I get that AD plus DB is your AB. Or what I can do is, the length of AD is same as the length of DB. Therefore, in place of DB, I can write again AD. That is your AB. Or I can say twice of AD is AB, or AD is AB by 2. Understood? Suppose I mark this length as R2 and this length as R1. Okay? Now, the question is saying what? It is saying find the ratio of the volumes of the upper part and the cone. So, there are two cones now visibly that you have. One is the smaller cone and one is this larger cone. What is the aim? Aim over here is to find the ratio of the volumes of the smaller cone to the larger cone. So, volume of the smaller cone or the upper cone to the volume of the larger cone. This is what we need to find over here. Now, what is the thing that I am going to do in order to proceed to get to this ratio? Well, let us observe Suppose I say this point is E. Let us observe these two triangles. Which two triangles? Consider triangle ADE. So suppose this is your triangle ADE. In this triangle, you can very well observe this angle is 90 degrees. This angle is something I don't know. This measurement is R2. And then you proceed with considering angle ABC. Bigger triangle. This triangle, triangle ABC, again has this angle as 90 degrees. I don't know what this angle is, and this measurement is R1. Now, one thing you need to understand from these two triangles, both of them are right-angled triangles. Now, what you do is, you consider this side AB. When you consider this side AB, first you have to consider this side AB, then consider these two lines. Consider the line DE and BC. So, there is a line DE and there is a line BC. Both these lines are passing through the transversal AB, and so these two angles will be corresponding angles, right? But because these two lines, which is DE and BC, they are parallel lines, that is why this angle and this angle will be equal to each other. We know, we have studied it in our 9th standards, that if this is a transversal and two parallel lines pass through it, then the corresponding angles which come as a result become equal to each other, and that is why this particular transversal is this. These are the two lines, and so this angle will be equal to this angle, which is 90 degrees. And so I know by this concept, angle ADE is equal to angle ABC. Also, now you can consider AC as the transversal. If you consider this AC as the transversal, this also has two lines passing through it, DE and BC. So, this is your DE and this is your BC. Understood? Over here you have DE is parallel to BC, isn't it? Because your DE is parallel to BC, the resultant corresponding angles which are coming as a result of these two lines intersecting this transversal, because these two lines are equal to each other, because DE is parallel to BC, not equal, they are parallel to each other, that is why these two angles will be equal to each other, resulting that this angle and this angle both will be equal to each other. Now, this angle is an angle in this triangle and this angle is an angle in this triangle. So, you have angle AED is equal to angle ACB. And so, these two arguments have given us that this angle is equal to this angle. That means there are two triangles ADE and ABC such that corresponding two angles are equal in both the triangles. Angle ADE is equal to angle ABC, and the second angle, angle AED of this triangle is equal to angle ACB of this triangle. That means by AA similarity, we get that these two triangles, triangle ADE, the smaller triangle, is similar to triangle, bigger triangle, which is triangle ABC. And you know two triangles are similar if and only if their corresponding angles are same and corresponding sides are proportional. So over here automatically this angle will be equal to this angle and also the sides will be proportional. So you are going to have DE upon BC this will be equal to AD upon AB. That will be equal to AE upon AC. Okay. Now what is DE? DE is R2 and BC is R1. So you get that this implies R2 upon R1 is equal to, what is AD? We know that AD is half of AB. So here you write half of AB upon AB. This gets cancelled. You get R2 upon R1 is half, or R1 is twice of R2. You have got a relationship between R1 and R2 that R1 is nothing but double of this R2. Once we have got this, do not forget the aim. It is find out the ratio of volume of the smaller cone to the volume of this larger cone. So let's do that. Just keep yourself reminding that R1 is equal to twice of R2. So as your R1 is equal to twice of R2 and we know what our aim is, let's proceed with making that aim to be true. So R1 is twice of R2. Using this result, let's see if we can find the ratio or not. So consider volume of the smaller cone to the volume of the larger cone. Now you know what is the volume of a cone with height h, radius of the base to be r. That right circular cone has volume 1 by 3 pi r square h. So right now what volume of the smaller cone with height equal to AD, radius of the base equal to R2 will be 1 by 3 pi radius of the base square into the height, which is AD. What is the volume of the larger cone? 1 by 3 into pi into radius of the base whole square. Radius of the base is R1 and height is AB. So you get R1 square into AB. And now 1 by 3 and pi, they get cancelled. You know that R1 is twice of R2, so you get what? You get R2 square upon R1 square becomes twice of R2 whole square multiplied by AD is nothing but half of AB upon AB. These both they get cancelled. Then you are left with R2 square upon 4 into R2 square into 1 by 2, which cancels these two out and you get 1 by 8 as your answer. And thus the ratio of the volume of the smaller or the upper cone to the larger actual cone is 1 by 8. Very nice question related to triangles. Now this has also used the concept of similar triangles rather than also use the concept of volume of a right circular cone. So this is one of the most important questions I would grade it as, because it's using cone as well as triangles concept. Not just the volume but also the similarity concept. And that is why this question was one of the most interesting questions that I could encounter. So I'll suggest you to practice it very nicely, understand how we have kept ourselves convenient in finding this ratio by using similarity of the two smaller triangles. One smaller triangle and this one big triangle. We proved them to be similar by A similarity, and then by using the meaning of similarity that the sides will be proportional, we also came up with a relation between both the radius of the bases, and therefore that helped us to get a number as the answer in the ratio of these two volumes, which is 1/8. Note this down quickly, understand it, spend some time with it, and then we are going to proceed with the next question. Okay students, let's now deal with the next question, which is question number 21. Take a look at it. Another very interesting question. Try to understand what it is trying to speak, and then we are going to solve it further. So what is the question saying? It is saying there is a circle with center O. Okay, so there is a circle with center as O. Okay, then it is saying that center is 2a comma a minus 7. So the coordinates are given to you, 2a comma a minus 7. They are the coordinates for a certain a. If the circle passes through the point 11 comma minus 9, so there is a point on the circle which is 11 comma minus 9, somewhere on the circle, because this circle is passing through this point. That means this point is lying on the circle, and that point is 11 comma minus 9. Suppose that point I am naming it as point A. And the diameter of the circle is 10 root 2 units. Now diameter is the longest chord. So if from this point A I draw the chord passing through the center, meeting somewhere here at point B, I don't know what that point is, then this AB will be nothing but the diameter of the circle, right? And so AB is what is given to you in the question as 10 root 2 units. So it's just unit. Meters or centimeters is not given to you. So let's just keep it as units. Find the value of A. Now, right from the point where the question started, it was A which was a known. So we had already guessed that the question would be asking us to find the value of A. Now that the picture is clear to us, let us now proceed solving the question. Right now the first aim is to somehow get the point B's coordinates. Now understand, O is the center. That means O is the midpoint of the line AB, right? If O is the midpoint of the line AB, that means, can you tell me the formula of finding the midpoint of a line segment joining a point A, which is x1 comma y1 as the coordinates it has, and point B, which has x2 comma y2 as its coordinates. That means if there is a line which joins A and B, then can you tell me the coordinates of the midpoint? What are the coordinates of the midpoint? Given again by the section formula, x1 plus x2 upon 2, and the yth coordinate becomes y1 plus y2 upon 2. Now once x and y have been found, that means you have found the coordinates of the midpoint of the line segment joining the points A and B. And so this concept, once you know, you can use it right over here, because O is the midpoint of the line segment joining A and B. Therefore, what will be the coordinates of O? X, the exit coordinate, which is 2A, this will be equal to x1 plus x2 upon 2. So x1 is 11, x2 is x. So 11 plus x upon 2. And the y-th coordinate, which is a minus 7 of the midpoint, will be equal to y1 plus y2 upon 2, where this is y1 and this is y2. So it will be y1, which is minus 9 plus y upon 2. Understood? As I told you, the aim is to find the coordinates of point B. So let's find out the values of x and y from these two relations. You have 4a minus 11 is your x, and from here you have what? 2a minus 14 plus 9 is y. So 2a minus 5 is your y. Okay? Now that you have your x and your y, therefore, you know that b is now not x comma y, but it is equal to 4a minus 11 comma 2a minus 5. Once you have the coordinates of point B as well, which are now no more x comma y, what are they equal to? They are equal to 4a minus 11 comma 2a minus 5. Now, how are we going to find the value of a from here? Well, we haven't made use of the fact that the length of AB is 10 root 2. Have we made use of this fact? No, we haven't made use of this fact yet. Now, if I am saying the length of AB is 10 root 2 units, this means the distance between A and B is 10 root 2. By using the distance formula, let's find out what is the distance between A and B. So, distance between A, which is 11 comma minus 9, and B, which is 4a minus 11 comma 2a minus 5, is what? What is the distance between these 2 points? So just consider this to be x1, this as y1, this as x2, and this as y2. Then the distance is given by under root x2 minus x1. So 4a minus 11 minus 11, x2 minus x1 whole square plus y2, y2 is 2a minus 5 minus y1, minus 9 makes it plus 9 whole square. This is the distance between 2 points A and B of this circle. But the distance between A and B is given to be 10 root 2 units. So this is going to be equal to 10 root 2. Understood? Now that you have this, in order to remove the under root, we know it's the distance, it can never be negative. So when you square both sides, what is it that you get? You get 4a minus 22 whole square plus 2a plus 4 whole square equals 10 square into 2. Because 10 root 2 whole square is 10 square into root 2 square. So that is 10 square into 2, which makes it 200. Understood? Now let's sort this out. This will be what? 4a square will make it 16 square, 16a square, plus 22 square will be 484 minus 176a. Once you have this, you have plus 2a plus 4 whole square, which is going to give you 4a square plus 16 plus 4 2 8, 8 into 2 16a. Understood? Is equal to 200. You just collect the like terms. 16a square plus 4a square gives you 20a square minus 176a plus 16a. So what is 176 minus 16? It is 160a. Then you have 484 plus 16. So this will be what? 6, 4, 10, 8, 1, 9 plus 1, 10. This is going to give you 500 and that is equal to 200. Now from here you can very carefully see you can take out the entire 20 common. When you take out 20 common, what is it you're left with? A square minus 20 into what is 160? 20 into 80 is 160. So you get 8 over here because 0 gets cancelled, 2, 8, 16. So you get 8a. Understood? Now 20 into 8 was 160. 20 into what is 500? 20 into 25 is 500. So you get plus 25 equals 10 because 20 into 10 is 200. So I took out 20 common. 20 into 8 is 160. So here you're left with 8a. 20 into 25 is 500. So here you're left with 25. And here also you can take out 20 common because 20 into 10 is 200. You're left with just 10 over here. 20 gets cancelled from both the sides and you have this expression left with you. Sort this out even more. You have a square minus 8a plus 25 minus 10, which makes it 15 equals 0. Nothing but a quadratic equation. Try to break the middle term. Very easy. A square minus 3a minus 5a plus 15 is 0, which will be what? A minus 3 minus 5, a minus 3. Collect the like factors. You have a minus 3, a minus 5 is 0, which means a will be 3 or 5. And therefore, the value of a is revealed to you. The value of a, which when plugged in at this particular point O, will make O the center of this circle, which has diameter as 10 root 2 units. Understood? That is how, by using coordinate geometry chapter coming into existence in order for us to deal with this question, we have made use of the concepts of finding the midpoint of a line segment when you know the 2 points which are joined by the line segment, and also by using the distance formula in order to use the diameter given in the question to actually find the value of the unknown small a. That is how we have dealt with this particular question. Entirely a question related to coordinate geometry. We have used the section formula as well as the distance formula in order to deal with this question. And that is how you have to combat all the trouble of the question. Very easy question, just you have to know the section formula and the distance formula and you can deal with this question like anything. Let's move forward and see what is question number 22. It is dealing with arithmetic progression. It is saying in an AP, the sum of first n terms is this. The moment it is giving you the sum of first n terms, the first thing you should know is the concept of sum of first n terms. So, I know that if AP has A as the first term and B as the common difference, then So if small a is the first term of this AP and d, small d is the common difference of an AP, I know that sum of first n terms denoted by Sn is what? It is nothing but n by 2, 2a plus n minus 1 into d. Isn't this? It is n by 2, this small n, sum of n terms. First n terms is n by 2, 2 times the first term of the AP plus n minus 1 times the common difference. Also, one more concept you should be able to recall, that the nth term of the AP is nothing but sum of the first n terms minus the sum of the first n minus 1 terms. That is going to give you a term which is equal to the nth term of this AP with common difference A, common difference D and first term as A. Once these concepts are known to you, let us utilize our very information of first n terms of this AP is given to us as 2n square by 2 plus 3n by 2. So Sn is given to us as 2n square by 2 plus 3n by 2. Now once this is given to us 2n square by 2 plus 3n by 2, I am asked to find its 25th term. That means I have to find A25. Can I find terms of the AP with the help of sum of n terms? Yes, I can, because nth term of an AP is sum of first n terms minus sum of first n minus 1 terms. That's how the terms of an AP are connected to the sum of the first n or n minus 1 terms of an AP. And so if I wish to find the 25th term, it will be nothing but what? S25, sum of the first 25 terms minus sum of the first 24 terms. Where your sum of first n terms is given to you as n square plus 3n by 2. Okay? Now once you have Sn with you, can you find out Sn minus 1 as well? If you know Sn, you can definitely find out Sn minus 1 general formula, because whatever here is, that is being plugged in over here and over here. So over here, if n minus 1 is there, I am going to have Sn minus 1 as n minus 1 square plus thrice of n minus 1 whole upon 2. Sort this out, this will be n square plus 1 minus 2n plus 3n minus 3, this thing upon 2. Right? Now you can just take out the LCM, this will be 2n square plus 2 minus 2n plus 3n minus 3 whole upon 2. And then you have 2n square, let it be as it is, plus 3n minus 2n, so you're left with plus n. Then you have minus 3 plus 2, which makes it minus 1. That means you have your Sn with you and you have your Sn minus 1 with you, and therefore you can find out the nth term, which is Sn minus 1, that is n square plus 3n by 2 minus this thing, which is 2n square plus n minus 1 whole upon 2. What will this be? So this becomes 2n square plus 3n. Then you have minus 2n square minus n plus 1 whole upon 2. This leads to the cancellation of 2n square, 2n square, 2n square and minus 2n square. 3n minus n gives you 2n plus 1 whole upon 2, which makes it n plus half. Understood? And therefore you have an is equal to 2n plus 1 whole upon 2 or n plus half. The moment you have the general formula for an, you can find out any term of the AP. Right now we are supposed to find the 25th term of this AP. What is the 25th term of this AP? The 25th term of this AP will be A25, which is whatever is the value of n that is plugged in over here and half is added to it. So the value of n is 25, so you get 25 plus half. What does that give you? What is 25 into 2? 50. 50 plus 1 by 2, which is 51 by 2. Understood? This is what happens to be your 25th term of this AP. And therefore, by just using that one connection between sum of n terms of an AP and the nth term of an AP, I was able to use the information of the sum of first n terms and hence from that find out the 25th term. That is how I have first found Sn. It was already given to me. From that I found Sn minus 1, and from that I found the general term of an AP, which is how An looks, and then by substituting in place of n25 I found A25. And that completes the solution of this question. Note this down and then we are going to complete the next question. So students, we were completing this particular question related to AP. Over here in the calculation there was a slight mistake committed. What will be here the status of 2n? This 2 gets multiplied this 2 and here you get a minus 4. The moment you get minus 4, here you have minus 4 plus 3, that gives you a minus 1. The moment you have a minus n over here, what does it become over here? This becomes plus n. And then you have plus 3n plus n, which delivers you with a 4n. The moment you have a 4n plus 1 by 2, you are left with 2n plus half as your general term of an AP, and therefore A25 will be 2 into 25, which is 50 plus 1 by 2, which is not 51 by 2, but instead it will be 101 by 2, 50 into 200 plus 1 by 2. That is what happens to be your 25th term of this particular AP. The moment we are done with this question, let's proceed understanding what happens to be question number 23. Try to read it, understand what it is trying to ask you, and then we are going to begin solving it. What is the question saying? The question says there is a circular track. Okay. So there is a circular track. Okay. This is what is your track. The question is saying the inner edge of a circular track has diameter of 70 centimeters. So the diameter of the inner circle is, suppose this is your center, this diameter is 70 centimeters. Suppose this center is O. And the track is 2.5 meters wide. So if the track is 2.5 meters wide, that means this length is 2.5 meters. And the cost of laying bricks is 12 per meter square. The cost of laying bricks on 1 meter square area of this track is 12 rupees. Find the total cost of laying the bricks on the entire track. That means first of all, if I know that the cost of laying bricks on the area of 1 meter square is rupees 12, what is the cost of laying bricks on the area of this entire track? So for that, I will have to find out the area of this entire track. What is the area of this track? The area of this shaded track is nothing but the area of the bigger circle minus the area of the smaller circle. right? Suppose this is your circle 1 and this is your circle 2. So area of the track is area of circle 1 minus the area of the smaller circle, say circle 2. Okay? Now what is the area of a circle? Whenever you know the radius of a circle, you can find out the area of that circle. Right now, if I talk about the inner circle, the diameter is given to be 70. If I talk about the smaller circle, C2, I know the center is O. If the diameter is 70, what is the radius? Radius is half of the diameter, which is 75 by 2, which is 35. And so, R1, which is, or R2 I should say, R2 which is the radius of the smaller circle, circle 2, is 70 by 2, which is 35 meters. Okay? Once you have the radius of the smaller circle, you can find out the area of the smaller circle, which is pi r square. So this is pi into 35 square. Okay? The moment you will be able to find this, next we are going to proceed with circle 1. Now what is the area of circle 1? In order to find the area of circle 1, I need the radius of circle 1. Now understand, this is the center. So if this is the center and this is a good circular track, this is the center, this portion, this much length is 35. From here to here, the length is 35. The extra length is 2.5. So from this point to this point will be the radius of the bigger circle. The radius of the smaller circle plus this extra portion, which is the width of the track, is what is the radius of your bigger circle. So what is the radius of your bigger circle? It is 35 plus 2.5. You have your bigger circle with, again, the center is the same as O, and now the radius, which is R1, is what? 35 plus 2.5, which makes it 37.5 meters. That means the radius of the bigger circle C1 is 37.5 meters. Once you have the radius of the bigger circle, what happens to the area of the bigger circle C1? That is again pi r square. So you know what pi? 37.5 whole square. So could you calculate this? This is going to come out to be 3850 meter square. This particular area is going to come out to be 3850 meters square. This is the area of the smaller circle. And the area of the bigger circle is what? This is going to come out to be 4419.6 meters square. This happens to be the area of the bigger circle. This entire area. And so, if you wish to find the area of this track, it will be nothing but the area of the bigger circle minus the area of the smaller circle. What will that be? Area of the bigger circle minus area of the smaller circle, which is 4419.6 meters square minus 3850 meters square, which gives you 569.6 meters square. And therefore, area of the bigger circle minus area of the smaller circle is nothing but the area of your track. The moment you have the area of your track, that was the first motive to find out, because I know that the cost of laying bricks on the area of 1 meter square is rupees 12. And so, what is the cost of laying bricks on the entire track? That is dependent upon the area of the track. What is the area of the track? So, cost of laying bricks on area of 1 meter square is rupees 12. Therefore, cost of laying bricks on the area of 569.6 meters square, because this is the area of the entire track. So, the cost of laying bricks on the area of 569.6 meters square is 569.6 multiplied by 12, which is 6835.2 rupees. And therefore, once you have your area of the circular track with you and you know what is the cost of laying bricks on 1 meter square area, you will be able to know what is the cost of laying bricks on this much area. It is nothing but this much into 12 rupees, which is 6835.2 rupees. And that gives me the total cost of laying the bricks on the entire track. Okay? Very easy question. In fact, this basically used twice the same formula, which was the formula of area of a circle. Because a circular track demanded 2 circles in picture, we had to use the same formula of area of a circle twice, and then we subtracted the area of the smaller circle from the area of the bigger circle, and we found the area of the left out portion, which was nothing but our track. The moment we found our track, we could find the cost of laying bricks on the entire track, because I know the cost of laying bricks on 1 meter square area. Having dealt with this easy question, let's move on to the last question of section C. Again, dealing with something like circles and tangents, let's see what this question has to say to us. It is saying in this given figure, this is a circle with center O. Determine the angle AQB. So, this is the angle which the question wants us to determine, and also the angle AMB. If PA and PB are tangents. So, these are the two angles which we have to determine if PA and PB are tangents. Now, understand again the same scenario is happening over here like it was happening in the very first question of section C. There is an external point, from there 2 tangents are drawn. I know that the tangents meet the circle at exactly 1 point and they are perpendicular to the radius at the point of contact. Now, if O is the center, OA is the radius. So, PA tangent will be perpendicular to OA. If PA tangent is perpendicular to the radius OA through the point of contact A, that means what is the angle PAO? Angle PAO is 90 degrees. This angle will be 90 degrees. Further, over here also PB is a tangent which is meeting the circle at exactly 1 point B, and OB is the radius. So, PB will be perpendicular to OB. Because again tangents are perpendicular to the radius at the point of contact, that means this angle is again 90 degrees, which means PBO angle is your 90 degrees. That means this angle I know. I also know this angle is given to be 75. Can I not find out this angle? Of course I can. How is this quadrilateral given to me in picture? This is somehow the quadrilateral. This is your point A, this is point B, A, this is O and this is B, this was P. Here is 75. This is your 90. This is again your 90. You don't know what this is. Again, this is a quadrilateral. By angle sum property of quadrilateral, we know that the sum of all these four will be 360, and that means angle AOB will be 360 minus the sum of all these three angles, which is 90 plus 90 plus 75, and this is going to give you 105 degrees as the value of angle AOB, this large angle. Now understand carefully. You have come to know the value of angle AOB. Inside the circle, if I roughly draw, what is it that you have? You have the center as O, okay. Now this center is here. This is your point A, this is your O, and this is your B. Apart from this, there is something like this also. This is your Q. Now, why have I drawn this portion is because you know this angle, this is 105 degrees, angle AOB. Now, angle AOB is the angle which is subtended by this arc AB at the center of the circle. Whereas, angle AQB is again an angle subtended by the same arc but at some other point of the circle. What is the relation between the angle subtended by an arc at the center and the angle subtended by the same arc on some other point of the circle? Well, I know that angle subtended by an arc at the center of the circle is twice the angle subtended by the same arc on the remaining part of the circle. Any point on the remaining part except the center, this is what is the relation. What does it say? By this particular concept, I know that angle AOB subtended at the center of the circle by arc AB is twice the measurement of angle AQB subtended by the same arc AB at some other point Q of the circle. So by this I know that angle AOB is twice of angle AQB, or angle AQB is half of angle AOB. What is half of? This is half of angle AOB, which is 105 degrees, which gives me 52.5 degrees. Okay? Once you have the measurement of angle AQB, one of the question marks is solved. You know what is the angle AQB. The only task is to find out angle AMB. Now understand the picture again of the circle. You have this as your circle, and what is the scenario there? This is what is the scenario. This is your point Q, this is A, this is B, and this is M, isn't it? M, A, Q, B, that is what there is, and this is what I have drawn over here, M, A, Q, B. Out of this, you know this angle is 52.5 degrees. Now, understand why have I separately drawn this portion. Over here, AMBQ is nothing but a quadrilateral whose all four vertices are lying on the circle. This means that AQBM, this is not just a quadrilateral, but because all its four vertices are lying on the circle, this is a cyclic quadrilateral. Once this is a cyclic quadrilateral, just recall all the concepts which you know about cyclic quadrilaterals. What are the concepts that you know about cyclic quadrilaterals? Because that is going to help me find out the remaining angle. The concept of cyclic quadrilateral said that the opposite angles in a cyclic quadrilateral are supplementary. It said opposite angles in a cyclic quadrilateral are supplementary. Understood? That means in this particular quadrilateral, which is a cyclic quadrilateral, angle at Q and angle at M, they both are opposite to each other. That means angle at M, which means angle AMB, plus angle at Q, which is AQB. They are going to add up to give me 180 degrees. That is what is the meaning of these two angles being supplementary, or I can also interpret it as that angle AMB will be 180 minus angle AQB, which is 180 minus 52.5, which is 127.5 degrees. This means angle AMB is 127.5 degrees and angle AQB is 52.5 degrees. That is how I have found both the unknown angles asked in this question by using the very concept of what all. So first of all, I considered the quadrilateral APBO, which is not a cyclic quadrilateral, and therefore I just used the normal angle sum property of a quadrilateral to find out the angle AOB. And then I used a very nice smart concept that the angle subtended by an arc at the center of the circle is twice the angle subtended by the same arc at any other point on the circle, and that brought to me the angle AQB. The moment I got the angle AQB, in order to find angle AMB, I considered this smaller quadrilateral, which is now a cyclic quadrilateral, and then by using the property that opposite angles in a cyclic quadrilateral are supplementary, I found the angle AMB as well. And that is how, by using the conceptual knowledge, we were able to deal with this question like anything. It was seriously very easy, just if you know all the concepts. When the concepts are at the tip of your hands, questions become very easy. They become cakewalk for you. So spend time clearing the concepts which are required to deal with the question, and these questions are basically going to give you the practice of all the concepts which you need. So practice these questions very nicely, understand the ideas which I have used in order to solve these questions, because the ideas are going to be used further in your life. Okay? These questions are not the exact questions which will be repeated or just copied in your question paper, but the ideas will be completely the same. So spend time with them, practice them, and next time we are going to meet solving section D. Thank you.